Hi there, I'm Clément Oblot. Today we're gonna have a look about structure and how to pack structure. Here we got two structure, but they are basically defining the same things, but one of them is gonna take a lot more space than the other one. As a matter of fact, one of them is gonna take 4 bytes more space in memory than the other one every time you instantiate it. If you make an array of 50 of them, for example, you're going to have 4 bytes times 50, so that's going to be 200 bytes more of wasted memory in your embedded system. Let's see how to detect that and how to optimize for that. In this video, we're going to be doing our test on that dongle, which is going to be using the NRF52840, which is a 32 bits microcontroller. That's going to be important, as we'll see later. Should be more or less the most standard case with 32 bits microcontroller, but you're going to have to adjust your calculation based on how many bits your microcontroller got. Here what I'm using is the NRF as a Nordic example that they are providing you with a CLI command in it. That way we can interact with it a little bit more. What I'm doing is that I'm just added one new command that is going to be struct command that is going to allow us to test for different sizes of structures. And for that we're going to try by building first of all a structure with just 1 in 32. And we're going to see what happens in that case. Monitor it, we can see starting, and we got our structure command. And when we start that command, we're going to see size equal 4. So in our code, what it's displaying is the size of my structure. That size of is going to be the key tool that you're going to need to test and validate that your calculations are actually right when it comes to the structure of the size of any structure, object, or whatever. So in that case, what we can see is that it's giving us a size of 4 bytes for something that we instantiated containing only a uint32. 4 bytes for 32 bits of data. Everything sounds perfectly fine. Now, let's add another variable just after it, and we're going to define it as uint8. And that one, we're going to rename var1, var2, and we can build it. Fine, we're going to write it. And we can see that the size of our brand new structure that is only going to use 1 more byte of actual data is actually taking 8 bytes. What the fuck? By adding 1 more byte, we end up taking 4 more in total in memory. How? Well, it all comes down to the bus size of your microcontroller. In our case, as I said, we got a 32 byte width of bus in that microcontroller, which means that every chunk of memory is going to be, every block of memory is going to be 32 byte long. To build a structure, it's going to take a certain number of chunk of slots of memory to build your structure. In our case, the first one is going to contain var1, and then we ask it to build var2 in it, which takes only 8, so it's going to fit into the next block that is 32. The only issue is that we got 3 sub-blocks that are unused in our case. No worries, the structure doesn't need it, but the issue is that the compiler is not going to allocate them to something else, another part of the application or what. What it's going to do is just going to leave them unused. So the way our structure is going to be in memory is going to be our var1 that is 32 bits, our var2 that is 8 bit, and then we're going to have 24 bits that are going to be useless. We can push those problems even further. If we start creating a variable, once again, of size 8 bits, then one of 32 bits, then another one of 8 bits, what's going to happen? Well, it's simply going to allocate one memory slot of 32 bits, just gonna use 8-bit in it, and then we ask it to allocate 32 bits, which is not gonna cut it in 2 blocks, one of 3 bits, 3 bytes, and one of 1 byte. No, it cannot cut a variable like that. So what it's going to do is going to leave those three bytes useless and take the next memory slot for that 32-bit variable. And then again we get in the same process, so like we ask it to allocate variable 2, var2 in our case, that is just 8-bit long. But what it's going to do is like not going to put it next to var0 where it has plenty of space that is unused. No. We ask it to put it after var1, so it's going to do that. Put it after var1 and so allocate another block in memory. Now, we can actually easily repack that structure, that's called structure packing, by telling it like, oh, actually don't bother putting them in that order, we're going to reorder them to optimize that memory. If we simply just move var2 one line above, what it's going to do is be, oh, I got the first byte to allocate for var0, oh, another one that is going to be for var2. Those two can live in the same memory slot of 32-bit, no worries. And then we got var1 that is going to be at the next slot. By doing that, we reduce the size of our structure from 12 bytes to only 8 bytes. Just like that, we save 30% memory by moving a variable inside of our declaration. Doesn't change anything in our code, just the order in which we define our variable inside the structure can make a huge difference. Now, to make it clearer, and not everybody in C is actually paying attention to those issues, but in most of the projects that I worked on, that becomes an issue at some point. You always are lacking memory in embedded systems. You want to develop a new feature and it's already full. Now, when you are packing a structure, I would advise you to actually comment it and make it clear that you pay attention to it and that other people should pay attention to it when they are modifying a structure. What I tend to do is to do the calculation in my head, and so in that case what we would do is var0 is going to be byte 1, var2 is going to be byte 2, and then we jump to var1 that is going to be 4 bytes. Then you're going to have 2 bytes of waste that are going to be in memory. So what you do is you comment that there is a padding of 2 bytes at that slot. And then usually what I tend to do is at the end of the structure, I comment total size, which in our case is going to be 8 bytes in that case. So there, with those comments, if somebody comes in and want to add a new variable to it, it's going to be clear that you want to add that variable as much as possible inside of the padding slots and remove those comments. For example, if you want to add a 16-bit variable, then you're going to remove that 2 bytes of padding and add your variable here, and that way you're not going to even increase the size of the structure. That's it for me in that case. I hope this makes the structure, the concept of structure padding a little bit more clear, and I hope it helps you optimize your memory footprint in your next project. See you! Packing, bear. Wait, what? The packing bear? Don't know about the packing bear. Is he delivering packages? Is he delivering my printer? Oh, I want that. Print a bear.